Hello, welcome, hearty welcome to you. In this session, we will look into geometric progressions, how to find out the sum of n terms or sum to n terms of a geometric progression. We know that a geometric progression looks like a plus ar plus ar square plus ar cube. I hope you remember this when we are trying to find out the nth term of general term of a geometric progression. Now Sn is given by this. We want to find out sum to n terms. That means we want to find out Sn. So for that, the last term will be something like a r to the power of n minus 1. Okay. What I will do, I will multiply Sn with r, and I will write r into Sn. So it will be nothing but equal to ar square ar cube, and you have ar to the power of n minus 1 plus ar to the power of n. So this is what you have when I have multiplied with r. Why I am doing that? So that I can cancel out the terms and I can get a simple formula out of that. Now when I subtract, what happens is, if I subtract now, I will see that all terms will cancel out other than the first and last term. So what I will left out is nothing but Sn minus r into Sn is equal to a minus a r to the power of n. So if I take Sn common, I will have Sn into 1 minus r 1 minus r equal to a into 1 minus r to the power of n. That's nothing but equal to Sn equal to a into 1 minus r to the power of n by 1 minus r, or you can also write it as Sn equal to a into r to the power of n minus 1 by r minus 1. So this is the formula to find out sum of n terms. What we have done? We know that we know that ar square ar to the power of n minus 1 are terms of a geometric progression. We have multiplied with r so that we can cancel out all the terms other than the first and last terms. When I subtract them, I will remain with Sn minus r into Sn equal to a minus a into r to the power of n, or simplification Sn equal to a into r to the power of n minus 1 by r minus 1. Now let's leverage this formula and try to do some simple problems. We have a problem. The geometric progression is given by 2 plus 4 plus 8 goes on. You have to find out sum of first 9 terms. So what is sum of first 9 terms? Is nothing but S9, and we substitute in the formula. You see that n equal to 9 now, so you will get a into a is nothing but equal to 2, and r is nothing but equal to a2 by a1. That's nothing but equal to 4 by 2 equal to 2. You know that now a equal to 2, r equal to 2. So I can write it as S9 equal to 2 into r to the power of n, that is 2 to the power of n is 9. So I can say minus 1 by r minus 1. That's nothing but equal to 2 minus 1. What we have here? A equal to 2, r equal to 2. We are using leveraging this. We are using that, and we are writing Sn equal to 2 into 2 to the power of n minus 1 divided by 2 minus 1. Now if you simplify this, 2 minus 1 is 1. So can I say 2 by 1 into 2 power 9 minus 1. 2 power 9 is 2 cube whole cube. That's nothing but equal to 8 cube. That's equal to 512. 8 8s are 64. 64 8s are 512. That's nothing but equal to 512 minus 1. So 2 into 511. That's nothing but equal to 1022. So sum of first 9 terms of a geometric progression is nothing but equal to 1022. Since it's a simple example, we can go back and cross check it. We have to find out sum of 9 terms. So let me write them out. 2, 4, 8, 16, 32, 64, 128, 256, 512. We are just cross checking. We'll not do for all examples like this. Since we are using it for the first time, we want to check whether the formula is working out fine or not, since it is a very simple example. Now try to add them up. 1, 2, 3, 4, 5, 6, 7, 8, 9. I hope I got all the 9 terms. You can add them: 768, 896, 960, 992, 1008, 1016, 1020, 1022. So the formula holds good. Sn equal to a into r to the power of n minus 1 by r minus 1. Let's do one more example, simple one. This is the example we have. How many terms of a geometric series or geometric progression 3 plus 9 plus 27 needed to give sum of 120? So we have a geometric progression. Since we know that we can find out easily a and r, we know Sn, we have to find out how many terms. That means we have to find out n. So in this formula we have to find out n. We know Sn, we know a, we know r. We have to find out the value of n. So let us do that. I will go ahead and say Sn equal to a into r to the power of n minus 1 by r minus 1. Now Sn is nothing but equal to 120, because the sum should be 120. We know a equal to 3. The starting number, first number is a, and r is equal to a2 by a1, that's equal to 9 by 3 equal to 3. So a equal to 3, r equal to 3, because 3 3s are 9, 9 3s are 27. So then I can say 3 to the power of n minus 1 by 3 minus 1. Now I have to find out, what I have to do is very simple. I have to find out the value of n. So let us do cross multiplication now. 3 minus 1 is 2, 120 into 2 is 240. 240 equal to 3 into 240 equal to 3 into 3 to the power of n minus 1, or I can say that 3 to the power of n minus 1 equal to 240 by 3, 80, or 3 to the power of n equal to 81. Now I have to write 81 as base of 3, so that's nothing but equal to 9 9s are 81, so 3 to the power of 4, so which gives me n equal to 4. So what we are saying now, 4 terms of this geometric progression needed to give a sum of 120. Let us cross check that. Since there are already 3 terms, 3 plus 9 plus 27, what will be the next term? The next term will be 27 3s 81. Add them up: 81, 108, 117, 120. So 4 terms of this geometric progression are needed to give a sum of 120. We'll solve some more examples in the coming sessions. That's about briefly about how to find out sum to n terms, and simple examples, couple of very simple examples just to apply the concept. Thanks for visiting. Bye for now. See you in the next session.